Good morning. Welcome everyone at the second day of the medical electronics event. Yesterday was a big success with 312 viewers for the 5 webinars we had yesterday. Today we still have 3 interesting webinars for you. We start today with Matthias Woodke from ODU. On behalf of Telerex is this presentation. The title of the presentation is Realizing IEC 606011. Protection from electrical shock in connector solutions. The speaker, Matthias Woodke, is situated in Leipzig, Germany, and the company ODU head office is situated in near Munich. In 45 minutes, he will tell you everything around this subject. If you have questions, you can already ask them during the presentation in the public chat. And at the end of the presentation of Matthias, we will answer. We will ask him the questions, and he will give you an answer on these questions. For now, let's say good luck for Matthias with his presentation, and for the viewers, have a nice presentation.
Yeah, thank you, Mark. And hello to everyone from Leipzig, where is my home office. And we are all in the same situation with this pandemic, so most of the people are in the home office. Today, I want to talk about a little bit more from the IEC 6601-1. But before I want to introduce myself, I'm Matthias Woodke. I'm the BDM of medical in Europe for a company ODU, which is a connector producer located close to Munich. And we are on the market and producing connector more than 80 years. So we have a lot of experience in this product. But coming back to the IEC 6601-1, which is the general requirement of safety and essential performance. And in this regulation, our focus goes on the medical electrical equipment. So now, let's see. I want to go to the next slide. Oh my God, sorry. Where's the button? Mark? Oh shit. I don't come to the next page. Oh, thank you. Thank you. On my next page, sorry for that. We see a normal situation. On the right side, you have a picture in a hospital room, which includes some stuff which you can find in a hospital. Means a bed, means monitor equipment, and the question is, how is the situation? What type of protection is needed here? The figure on the right shows you a typical hospital setting. The medical equipment in the vicinity that is not intended to make patient contact requirements to MOOP. What does it mean to MOOP? Look on my pictures and you see on the right side there is some stuff which has the name professionally operated medical equipment with no patient contacts. This equipment has this 2 MOOP. OOP stays for operation, means of operation protection, and it means that this equipment doesn't have any direct contact with the patient. Going back to the information, the ECG monitor has applied part of that, make a direct electrical contact with the patient. This parts required a BF, a body fluid rated electrical contact with the patient. These parts required a BF rating electrical connection. For more information, look on my pictures again on the right side. you see the monitor, the ECG monitor, with direct patient contact. Not in this picture, you see the monitor, but from the monitor goes cable, wire connection to the patient's body. And from that point on, you need this 2 MOPP. 2 MOPP, M stays again for means of patient protection, and you have the classification of BF, of body flow. So this classification tells you that you need a 2 MOPP. What does it mean? Going to the next page. The next page shows you an overview on the IEC 6601-1, which is built in 2012. And from that side, you have two different kinds of, let's say, parts of this norm. One part is the IEC 6601-1, third edition, which has a focus on patient and operation. And on the other side, you have the IEC 6601-1-2, which is built in 2014, which talks about more about electromagnetical compatibility. And this is part of medical electrical equipment. But today, our focus goes on the left side to the third edition. And the third edition, again, has a focus on the protection on the to the patient and the operation. And there we have on the left side this MOPP. What I talked before is means of operation, is the protection against the operator or the nurse. And on the other side, on the right side, we have MOPP, means of patient protection. So my focus for today is on this side is the patient. Why? The patient himself, he cannot react. He is sleeping on the bed. Maybe he cannot move. He has an operation, so he needs the highest protection of an electromagnetical shock from equipment or from the bed himself. Also, the bed has to be protected. And for that reason, we have three classifications. And you will find this classification under in my screen. We start with B, stays for body, and this is without direct contact from any electrical things to the body of the patient. Then we have BF, is the body float, is the direct contact with a cable, for example, ECG, which has a cable and a sticker on the body, and you have a connection to electrical equipment. So this is BF. Then we have CF, is cardiac float, is the direct contact to the heart. This is on an operation, for example, on a pacemaker operation, where you go inside the body, and there you have the highest classification. So now we have a need. We need these two Mopps, and we have a classification B, BF, CF, whatever. And now is the question how we can handle this. And there are two options. You can handle this from electronical sides, means your equipment has AC/DC medical power supply plus a DC/DC transducer. And with this application, you can have this two Mopp on your monitor on your equipment, or you can use an ODU connector which has a mechanical 2-MOP in the connector situation. So going to the next page. Next page shows you how we do it in ODU to have the protection against electrical shock in medical application. And on top you see again the norm. On the left side you see this MOOP has the focus on the operator. Here on this picture you see the nurse, and on the other side you have the MOPP, which is the patient protection, only for the understanding. And right side on my screen you see in this round bubbles 1, 2, 3 application where we have a 2-MOP situation integrate in our receptacle. Going to the next page, to give a clear picture how we reach the IEC 6601-1, I want to explain this on this slide. The slide shows you a selection view of a receptacle and a plug which is connected. On the left-hand side, you have the G1. The G1 has only one MOPP. Means this is not enough for the standard, what you really need. So the Creepage Distance is on this application only 4.5 millimeter. You see it, there's a red mirror here. And there you see the Creepage distance is the distance between the last pin inside the connector to the outside body. It's here a little bit with this red line which goes around the housing of the plug and the receptacle. This distance is right now on the G1 only 4.5 millimeter. To be conform with the IEC 6601-1, you need 8 millimeters. So 4.5 is not enough. What we in order can do to reach this 8 millimeters, you will find this on the right side. This shows you again a receptacle and a plug. We name this G9 or GA or G4, or this is a type of the receptacle. And what we change here is the nut of the receptacle is longer than on the left-hand side. You see this, you have here a smaller nut in blue than here on the right side. This is much longer. And if we're looking now for the Creepage distance from the pin inside to the outside housing, this is the part here, you have this longer way right now. And this longer way is 9.1 millimeter. So it's more than 100% more than you have before. And what I say before, you need 8 millimeter creepage distance. Now you have 9.1, so you reach the norm, and you can work with a normal standard receptacle. One positive thing on this is also, if you have installed right now such a one Mopp solution and you want to redesign your product, you have to, and you need this 2 Mopp, you have to change only the receptacle. The dimension of the receptacle is the same, and you get then you can install the new receptacle in the same hole what you have right now. So just for your understanding, a little bit more about clearance and creepage distance. You see it on the center of this slide. There's a picture which shows an isolation body with 2 pins, for example, and the blue line is the creepage distance. This is the distance from one pin to another pin, or the distance from one pin to the outside housing on the isolation body. And the clearance distance is the distance between 2 pins. And on the on my slide on the down, you can see also other application in the isolation body, how we can handle on a mechanical way to solve the 2 Mopps in an existing solution, only changing the isolation body of the connector. In the left side, you see an example for isolation colors, means we protect the pins with isolation, with an extra isolation. Then the next shows you an isolation domes, which shows you a protection to the pins himself, and also a longer creepage distance from the pins to the outside body. And then you have other picture which shows you different application for asymmetric layouts, means we have on some application high voltage pins and signal pins, and for that reason you must have different kind of design layouts, but we can do it. And also you can have an isolation sleeve around a contact to have a longer isolation. So going to the next page. On the next page, you can see existing connectors, which has the name MediSnap, which is right now conform with the IEC 6601. And I just want to explain you a little bit more to this page, and you see on the above, you see on the left side above 5 receptacle, which has right now 2 MOPP, means this is the protection to the patient, which is safe, which has this minimum 8 millimeters, but also 2 MOOP. And if you're thinking about my second slide with the picture of the operation room, this kind of receptacle you can use on all application, on all monitors. This save all application. If you look down, you will find other 8 different receptacles, which has only 1 MOPP. Means there is only 1 MOPP, and you cannot use them in direct contact with the patient. So, and on the right side, from my slide, you will see application for power connection, where we have integrated 2 Mopps on the receptacle and also on the plug. So also the plug has these 2 Mopps, and the receptacle also. These 3 and 4 pins, it's very popular to use them for power communication with the equipment, and yeah, these are some application what we have. So I'm right now on the end of my presentation, and I see there are some questions coming. But on the end, I will just explain you on the last page. You will find my email address and the internet address to the company. So if you have question later, you can contact me direct by email, or we will discuss this now. Mark.
Thank you very much, Matthias, for your presentation. We do have some questions for you. I see questions. I will start with the first one. The first one is from a question from Quincy.
Okay.
Do we have a 2 MOPP solution for circular metal connector?
Yeah, that's a good question. And of course, we are producing plastic connectors and metal connectors, and also for metal connector, we have application with 2 MOPP. And if you have a metal housing, the 2 MOP are much more important than on a plastic housing. Plastic himself, the material is an isolation material, and metal doesn't is an isolation material. So yeah, we have a solution, 2 MOP solution for metal circular connector also.
Is the IEC 6601 important for the new MDR regulation?
Yes, it is important. This is part of this regulation. I think in Article 12, they say about the protection to the patient and operation. So yes, if you have now, or you have a new design with your medical equipment, and you on the end of this you need your qualification, and you have to go to a notified body to get your certification to bring the product on the market, and you have to be under the norm of the IEC 6601 to protect the patient and the operator. So yes, it is very important.
Thank you. Another question from Wesley. So this creepage distance in the connector counts when using a 2 MOPP creepage to the panel material, metal, inside to outside of the connector?
If the panel connector, it's the panel inside the electronic, inside the monitor, or is it the panel which you touch from the monitor? The question maybe is if the housing of the monitor is in metal, you have another situation, then it's in plastic. And but for both situations, with our special application, we can solve and handle this situation that you have always 2 MOPP. Is this the answer?
Yeah, see one addition also from Wesley. He said touch metal enclosure as an addition to his question.
Yeah. Okay. Yeah. It's the metal part which you can touch, and this is why I explained you. We have this solution also in our circular metal connector, and on this you can see we can also protect metal part with this 2 MOPP. For this reason, it's the isolation body looks a little bit different, but you can think about we built some extra domes around the metal part to have this longer creepage distance.
Thank you. I also saw a question coming in, and maybe it's good to answer this question now. I saw a question from Bert. How about ESD? Also, of course, important.
ESD. Wow.
Yeah, the electric static discharge. Yeah. I don't know if you're an ESD expert or an ESD expert, but we can also maybe this question can also be asked answered later if you say.
Yeah. I want to answer this question later. Otherwise, maybe I don't want to struggle or talk about something what I'm not 100% knows. So I will come back later with an email to this question. Sorry.
Yeah. Okay, that was a question from Bert, and I think Hanneke de Bij from Telerex can note the question, and then we come back to that question afterwards. Then we have a question from Erik. What about the test finger, which can go into the connector body, thus reducing the creepage distance? Question mark.
Yeah, that's also a good question. Of course, in one of my slides, maybe we can go back to slide number 5.
Yeah, Martin is going to that.
Okay, and on slide number 5, you can see here. This is one in the here on this picture. This is one type to protect the contacts with an isolation domes around the pins. And if you go to the next page, Mark, you will see here in this a plug connector, which has also a protection. Maybe the picture is not big enough, but maybe you see there is an isolation just in front, and you cannot go inside with the electrical finger to have contact with the pins. This is also a very important rule for us to protect people if the plug himself has 230 volt or something else. We must protect the person who get in touch with the connector, with the plug. So for that reason, we just build the pin deeper inside the isolation, so that we doesn't come in contact with the pins himself. So, and this is always tested with the finger, with the power finger. Okay.
Thank you also for this question. Last question is from Wesley at the moment. Is it possible to share the part name of the connector solution for metal housing with 2x MOPP patient connection to the metal enclosure? I think that's maybe good to answer after the presentation, maybe, or do you want to name it now?
Yeah, I want to answer this later. It's maybe more complex, so let's write an email to this person and answer the question. Okay.
Right. I have a question from Erik. I think that's in addition to the last question. The question is also for 2 MOPP.
Yeah.
I think it was the question, an extra question to the question of. Let me see. Yeah, of Erik. What about the test finger, which can go into the connector body for reducing the creepage distance?
Yeah, this has also this 2 MOPP. This was in this slide. You can see also then you have this 2 MOPP. But this is a standard in. We make this test with the electrical finger on all our equipment. So, today we're talking about the patient and the operation protection, and then you need a little bit more isolation design, let's say, to have this 2 MOPP in your application. So it's always the distance between the pin and the outside body, or also the distance between the 2 pins inside a connector can be important. So it's up to the application. It's how many voltage you need. Is this only a signal? Is it high power? Is it RF generator or something else? So then you, of course, you need more distance, and also the protection to the housing. It's very important. But that's my answer.
Thank you, Matthias, also for answering this question. I see a question from Mario, if the presentation will be shared afterwards of ODU. Yes, we will send tomorrow to the viewers an email with the complete replay of the webinar. So you can see the complete presentation of Matthias again. And if you have questions when you're rewatching the webinar, you can also ask your questions in the chat then, and it will also be sent to TaylorX and to ODU. I see at the moment we don't have any questions. I wait for a couple of seconds if there are some questions coming in. No. So I would like to thank you very much for your presentation, Matthias Rutke from ODU on behalf of TaylorX. I see a question coming in last minute. So we have a question again. When is pin-to-pin creepage distance necessary? Is that when multiple AP are connected?
Yes. This is important when the equipment is connected, and also if it's connected, and if it's also connected to the patient, for example, the ECG with the cable. If this cable is connected, but also is important, for example, if you have this sticker which going on the body of the patient, and on the other side you have the wire, you have the cable, and you disconnect the plug from the monitoring, and the plug falling down to the ground, it can be this plug must have also security to protect this 2 MOPP. Then, for example, he can falling down, and if it's metal, for example, if it's a metal connector, he can get some power from the ground himself, or from the bed or something else, and bring it back to the body, to the connection on the body. So on that reason, it's also important that we have these 2 Mopp on this plug if it's not connected to the monitor.
Thank you very much. I see also a lot of thank yous on the chat. Again, Matthias, thank you for the presentation. Thank you also, Hanneke de Bij from TaylorX for being the moderator today. And of course, thank you for the viewers to watch the webinar. We have 2 more interesting webinars on the program today. At 11:30, the next presentation is from Herbert Bloom from Schurter Electronics with the title Connector Filter for Medical Applications. And on 1 o'clock, we have a really interesting presentation about EMC in hospitals. And the session is by Robert Voogd and Barbel van den Berg from University of Twente. So you can still register for these webinars via the website of the event. That's fhi.nl/medische elektronica. Thank you again for the viewers. Thank you again for the presentation. And we hope to see you again at one of the other webinars. Thank you and have a good day.